Is it x is equal to 7/2?
Yes. Yes. All right, number C, part letter C. Yet another kind of variation on this. So notice this problem has logarithms on both sides of the equation. So you have to get everything inside the parentheses, which means moving the 3 here and this negative here, -1 actually. So there's a property that allows you to move the base, or I'm sorry, the coefficient up as the exponent. You sometimes see it written like this: log base bx to the n equals n log base b of x. Basically that exponent goes in front, or when it's in front, it can go to the exponents there. So it becomes log base 2 of x squared, log base 2 of 27 to the -1 power, like that. That's a little bit awkward, so might prefer to rewrite it as 1 over 27. And because they both have a log base 2, or really any base, but because the logs are the same, you can set the part inside equal to each other. I'm sorry, that's a cube, not a square. Apologize.
Oh yeah.
All right, now to undo a cube, use a cube root. Cube root of both sides, so x equals 1/3.
Okay. Okay, got it.
Great. So the next question here, letter D. The natural log undoes the e. So if you had the natural log of, say, e to the x, it just becomes x or whatever's in the exponent. So when you have natural log of e to the -2x, it becomes just -2x equals 8. The 8 just comes down. You solve this as usual. X equals -4.
Oh, yeah, that makes sense to me.
All right, so let's keep going here. I didn't see that there was E's, E, F, and so on here. All right, so there's more logarithm properties. The next one is that a sum like this becomes a product. It's really any base. So it becomes log base n of a times b.
Okay.
All right. And that becomes, so in this case, it becomes log base 2x. I'm sorry, x times x plus 2, like this, equals 3. So it becomes a product there.
Okay, got it.
Now, we did this in the last problem, or this one up here. You undo it with the base, like whatever the base is, you undo it. So in this case, you put a 2 underneath. Okay, and then on the left, it just cancels. So you get x times x plus 2 equals 8. And then you distribute in, so you get x squared plus 2x equals 8.
Okay, got it.
And then you have to solve this still. So you move the 8 over, x squared plus 2x minus 8 equals 0. And then you have to factor. So you have to find two numbers that multiply to -8, but add to +2. So -8, +2, can you
Yeah, hold on. You could do +4 and a -2.
Very good. You set both of these equal to 0. And you get x equals -4, x equals 2.
Okay, got it.
Now, unfortunately, we have to check our answers. Like one of these is extraneous. And most of the time it's the negative one, most of the time. But you're really supposed to go back and check. And the issue is that you can't take the log base b of like this number, whatever's inside there has to be positive. So without getting into a lot of like discussion about why it is, it's related to the graphs we did last time we met. This one is crossed out. It's called extraneous, which means that it just doesn't work, even though it's a solution to the quadratic.
Okay.
Okay. I think I mentioned this the other. These are not short. Like each one of these are just sort of a lot of stuff going on here.
Yeah.
Right. So this is one of those like convert from a log to an exponent or an exponent to a log, becomes log base 3 of 14 equals x. Okay. And this is just one of those straightforward, like you just map the letters or the numbers into the positions. So that this is your answer. It's log base 3 of 14. That's it. You don't have to do anything else. Now you could put it in the calculator. You don't need to. This is considered exact. And this is what they want.
Okay. Sounds good.
All right, so G. Okay, E, to undo E, you use ln. So you have to take the natural log of both sides of the equation. On the left, we did this earlier, the E is undone by ln, just the exponent is the result.
Okay.
The difference is in the earlier problem, we had something a little bit nicer over here. I think it was like a number, like 8 maybe, but whatever, we got it here. To solve for x, it's the standard stuff we always do. You subtract 1, but there's nothing to subtract 1 from. Like natural log of 13 and -1 are not like terms. So you just leave them. It's just an expression. And then you divide everything by -2. So if you wanted to, you could clean the signs up a little bit. Like you can call this over 2 and then put a -1 in the numerator. And what that does is it flips the signs. It ends up being 1 minus natural log of 13 in the numerator over 2. Basically just distributing in that -1. Any of these are fine. You're gonna they're happy with any of those. So whatever you want to do there. Okay, H is by far the most difficult problem on here. It's a standard problem you see in college admissions tests, or placement tests when you get to college to see what class to go into. At first glance, you're like, well, how can you even solve this thing? Because the bases aren't the same.
Yeah.
It's like, well, what do we even do? Well, it's like the only thing you can do is take the natural log of both sides, because that at least gets the variable out of the exponent. All right, so we got, and now very important to remember that it's really x plus 1 in parentheses. X plus 1 natural log of 2 equals 1 minus 2x natural log of 5.
Okay.
Really important, because even though it's natural log of 2 looks weird, it is a number, just some sort of number. We don't like it. You're distributing that to both of these. So this is x natural log of 2 plus the natural log of 2. You can put a 1 there in front if you want. Same thing over here, natural log of 5 minus 2 natural log of 5 times x, like that.
Okay.
And you're just distributing in. In the order how you write it, I mean, you could put the x in front if you want. A lot of ways to write it. You now want to get all x terms on one side. Okay. So to do that, we want to move this x term on the right to the left, and this natural log of 2 to the right. So to do that, add 2 natural log 5 of x to both sides. And then subtract the natural log of 2 from both sides. Now nothing combines, like it's not like they're like terms, you just rewrite it. X natural log of 2 plus 2 natural log of 5 times x equals natural log of 5 minus the natural log of 2, like that.
Okay.
And it looks really bad, really, really bad, but we're almost there, believe it or not. Both the terms on the left have an x in it, and you can factor them out.
Easy.
So that's natural log of 2 plus 2 natural log of 5. Same right-hand side. And then, as horrible as it looks, it is just a number, and you divide both sides by that number. What does it all mean? I have no idea. It doesn't mean anything, but it's a math problem that they have you do. And there it is.
Hold on. Okay, got it.
Okay. Number 12, like I mentioned, these are really slow. Everything, there's a lot here. But,
Yeah.
all right. All right, a model for the number of people in high school who have heard a certain rumor is n equals p parentheses 1 minus e minus 0.15d, where p is the total population of the school and d is the number of days that have elapsed since the rumor began. In a high school of 1,000 students, so that's p.
Okay.
P is the population, right? It says how many people in there. And then 3 is the value of b. So they're asking to find n equals 1,000, 1 minus e to the minus 0.15 times 3. So you'll need a calculator to calculate this. That's probably the hardest part, is putting it in the calculator correctly. Let me know if you need any help. The number.
Sure. I got 362.372.
Sounds good. Yeah, that's students. Would think it'd be faster than that, but that is the model in question. So that's part A.
Mhm.
This problem is so familiar. I've seen this one before. This was either taken from somewhere, or it's just a standard problem they give in this class. Same situation, but now they're saying, like, when will 900 students know? Basically, they're telling you, we want to know when n is 900, p is still 1,000. So that's 900 equals 1,000, 1 minus e to the minus 0.15 d. So they always have to give you everything but one. Like you can't not have the variable. So they want you to show your work. I mean, you gotta manipulate the equation. We'll work through that now. First thing is to divide both sides by 1,000. On the left, that is 0.9. 1 minus e to the minus 0.15 d. You essentially want to switch sides. I show it this way. You add e to the negative 0.15 d. You subtract 0.9. So on the left, it's e to the minus 0.15 d equals 1 minus 0.9, which is 0.1. And then from an earlier problem, how do we undo e? How do we get rid of e? We did that in G, 11G, for example.
You take the natural log.
Exactly, yeah. Natural log of both sides. Natural log undoes the e, so it just vanishes, and it's minus 0.15 d equals natural log of 0.1. We don't know what that is. We're going to go to a calculator, but we do have to divide both sides by minus 0.15. So d equals like this. Grab your calculator.
Yeah. Oh.
Let me know
I
what you
got
come up with.
15.35.
All right. And does that sound about right? Rumor takes about 2 weeks to get to everyone.
Yeah. Maybe a little quicker than that.
Yeah, maybe with social media, you can get there a little faster.
Yeah.
All right. Moving on. 13A. 13A. Let me know when you're ready for us to move on.
I'm ready.
Okay. All right. So it says to write each expression as the sum and or difference of logarithms. So basically there's two types of problems. There's expand, which we're seeing in this grouping, and then we're going to compress or condense in upcoming problems. So this one, you've got a top and a bottom, and the quotient, the fact that it's division becomes a difference. So it's log base 3 of 9v squared minus log base 3 of w. Hopefully you saw those formulas at class, the expansion formulas.
I got it.
All right. Now there's more to do because the one on the left here, it's a product. A product becomes a sum. But wait, there's more. The 9 can be written as 3 to the power of 2. And then we talked about this earlier. You can bring the exponent, the 2, out in front. You can bring this exponent of 2 out in front. So it's 2 log base 3 of 3 plus 2 log base 3 of v minus log base 3 of w. Log base b of b, whenever they're the same, it's always 1. So it's like log base 4 of 4, that's 1, or log base 8 of 8, it's 1. So log base 3 of 3 is 1. 2 times 1 is 2. And you just bring the other stuff down.
Got it.
I sure hope you're not expected to get all this in the amount of room that they give you on the page there.
I hope not.
There's a lot. This one's even longer. So
Yeah.
it may not look like it, but it's a product inside here. It's a product of x squared and the square root of x cubed plus 1. So there's a product of sum and then there's a quotient, the difference. This becomes log x squared plus log square root x cubed plus 1. So that's the start. The next part is a reminder that the square root of x means x to the 1/2. So on the right
Okay.
here, it's log x cubed plus 1 to the 1/2 power log x squared. In both cases, the exponent can come out in front. Two log x plus 1/2 log x cubed plus 1.
Okay.
And that is it. That's everything
Okay.
for that.
Sounds good.
All right. Now the next part here, it's going backwards, meaning that like instead of expanding, you are compressing. So we're basically undoing all the rules we just did. So in this one, the difference becomes a quotient. So x squared minus 9 on top, x squared plus 7x plus 12 on the bottom. Basically, like in the previous problems, they would give you this, and then you have to go backwards. Now we're going forwards.
Got it.
Okay, now the next step here, we haven't seen this, I haven't seen one of these in a while, is you have to factor the numerator and the denominator. All right, so the top one is difference of squares. That's x minus 3, x plus 3.
Mhm.
The bottom, you're trying to find two numbers that multiply to 12 but add to 7.
3 and 4.
So x plus 3, x plus 4. You see any cancellations?
Yeah, the x plus 3.
Yeah, no, we're not. I mean, this is, I'm a little surprised the way they're doing this, but log x minus 3 over x plus 4. Usually they don't have cancellations like this inside here, but that they do. So that's everything. I know, probably
Okay.
kind of like, God, just what does it all mean? I don't know. When you practice sports, like there's always like something you work on your serve, you work on your forehand, your backhand. Like I can't give you a good reason why we're doing this right now.
Okay.
You do use it again in calculus, but not this way.
Okay.
All right, so this again, you're kind of undoing everything. You will put the exponents first back inside.
Okay.
There's kind of a hierarchy here. 3x minus 1 cubed, log base 5, 2x minus 1 squared, plus log base 5 of x. Okay. So our focus will now be on the first two. Because it's a difference, it becomes a quotient. So it becomes log base 5, 3x minus 1 cubed, 2x minus 1 squared, plus log base 5 of x.
Okay.
The next thing here is that because it's a sum, it can be pulled back together as a product. Okay. And I think what's maybe awkward here, it's like, well, what it goes on the top, what goes on the bottom. It's really x over 1. So when you multiply these things, you keep the original 3x minus 1 cubed,
Yeah.
2x minus 1 squared, but you multiply by this x over 1, which is really just a.
Okay. Got it.
And that's it. I mean, you
Okay.
can you can maybe put the x next to the parentheses here, but that's yeah, it's a minor thing there.
All right. That makes sense.
All right. Okay, let's look at the next one here, 15. Okay, good thing to do here would be to graph this in Desmos calculator,
Okay.
just to kind of get an idea of what it roughly looked like. We'll get more specific with the points in a moment when we do the table, but a rough sketch of this is that you see it kind of looks like this when you graph it. And this is y equals 5. That comes from this 5 here. We can talk about some other things about it in a moment, but this helps with domain and range. The domain is all real numbers minus infinity to infinity.
Yeah.
Exponentials are always all real numbers. The range is the y values, like how far down does this go? How far up does it go? Minus infinity to positive 5. That's the max y value, but it never hits 5. That's why it's parentheses there.
Okay.
Asymptotes. This one has a horizontal asymptote at y equals 5. It's always, the horizontal asymptotes are always this number. It's really the vertical drift of the graph, which we'll get to in the transformations in a moment. There's no vertical asymptote though, just the horizontal in this case.
Okay.
Okay, let me actually rewrite the function. F of x equals minus e to the minus x plus 5. There are 1, 2, 3 transformations. The first one is the minus in front of the x. That's a reflection over the y-axis. The negative in front of the e is a reflection over the x-axis. And you might wonder, well, what's the difference? The original negative is inside parentheses. It's kind of like left-right stuff. It's the innermost stuff. And you can also talk about what affects x and y. The last thing, the plus 5, is the vertical shift of 5 units up. I guess we're going to say up.
Okay. Got it.
So that leads us to being able to graph this thing. I mean, you kind of already have a graph here. So there's a few key points that are worth graphing. If you can. One of them is 0. That's kind of the big one. So when x is 0, you have 5 minus e to the minus 0 power. Anything to the 0 power is 1. This ends up being 4. And that's one of those nice points. The fact that there's a horizontal asymptote at y equals 5, that's probably good to put in the graph. Other than that, like, I don't know, you kind of know how accurate you need to be.
I don't think it needs to be like crazy.
Yeah, so maybe just especially, I'm sure you're trying to get caught up here. We'll just say that's good. I hope that that's sufficient. B is kind of the same. Oh, and A's got the asterisk next to it, so you can kind of suggest that you use the calculator for it.
Okay.
All right. Again, kind of good to have an idea of what this graph looks like. If you were to graph it, you would find that it has a vertical asymptote at -2. And crosses there, it's there. So it's going to look something like this. And so the domain is not everywhere. The last one was everywhere. It butts up against this -2. It kind of pushes up against it, but it does go to the right forever. So it's
Okay.
all the numbers to the right of -2. So that's -2 to infinity.
Mhm.
The range, though, is all real numbers. All right.
Okay.
This
Got
one
it.
has a vertical asymptote this time at x equals -2. You'll notice that's where the inside function equals 0.
Mhm.
All right. And then transformation. This one actually only has one transformation. It's this inside part, the x plus 2. That means it's left 2 units. It's always opposite when it's inside.
Okay, got it. Also, if you hear anything, that's my sister's cat. She's going crazy.
Yeah, microphones aren't too, not that much. So,
Oh, okay, good.
all right. It's usually something like far away that I like. It'll be this really weird, noise that you're like, what is that? That microphones are pretty good. So we need to get a couple of points here. Log base 2 x plus 2. So we'll do, for example, when x is -1 and when y is 0, and maybe when x is 2. So the first one, log base 2 -1 plus 2 is log
Mhm.
base 2 of 1, which is 0. By definition, log base b of 1 is always 0.
Okay.
Log base 2 of 0 plus 2, you might wonder, why am I choosing that point? Because it's log base 2 of 2. We talked about this earlier. When these match, it ends up being just 1.
Okay, got it.
And then log base 2 of 2 plus 2 is log base 2 of 4. 4 is really 2 squared. You can bring that 2 in front. It becomes 2 times log base 2 of 2. Lots of 2's.
Yeah.
It's just 2. And so
Okay.
that's kind of enough, along with maybe that vertical asymptote at x equals -2. Couple of points. Something like this. And then don't forget arrows at the end. We're just kind of looking ahead here because I can see there's no way to finish all this. Do you want to kind of pick and choose problems? Like, for
Yeah.
example, you probably can graph the next grouping. What you tell me, where do you want us to go from here?
Could we maybe do 16?
I'm suggesting we not do 16, but it's your
Oh,
choice.
okay.
Just you can graph these, I think, and but it's up to you.
Maybe
You're the
we could
customer.
do maybe try to do 19 and then
Okay.
21 and 22 if we have time. But
All right, let's do it.
okay.
Okay, here we go. 19. 19A. Here it is. All right, so I couldn't snip in everything, but it says determine the initial amount of bacteria. What that means in terms of the function is you're saying, okay, T is 0. So what is N of 0? That's 600 E to the 0.044 times 0, which is 600 times 1. That's 600. So the initial amount is the leading coefficient here.
Okay. Which is 600.
which 600, yes, exactly. Oh, and you might want to say units. I don't know what it is. Bacteria. Part B. What is the growth rate? So it's the 0.044, but they usually want you to convert that to a percent. So you have to multiply by 100. 4.4% like that.
Okay.
Part C, what is the population after 5 days? They're giving you the value of t. They're saying t equals 5.
Mm-hmm.
N of 5 equals 600 e to the 0.044 times 5. And we'll go ahead and calculate that. It is growing, so it will be bigger. In this case, the population is increasing. It's got a growth rate of 4.4%. So when you get your number, you shouldn't be surprised if it's larger. So I get about 748 bacteria.
Okay, that's what I got too.
Awesome. All right. For 20 question or 20 odd question, this is probably like at least double the number of questions. Maybe if you counted all the parts, this might have been, 80 questions. So how long will it take to reach 1040? You're setting 1040 equal to 600 e to the 0.044 t. We have to solve for t. So to do that, you divide by 600. So you have e to the 0.044 t equals 1040 over 600. I did switch sides here. That's just kind of my preference to put the variable on the left.
Okay.
And so just like before, you undo both sides with natural log. 0.044 t, natural log 1040 over 600. 0.044 t equals natural log of 1040 over 600. And then you divide both sides by the number in front there. So t ends up equaling 1040 divided by 600 over 0.044. Definitely need a calculator for that.
Yeah.
There's not.
Oh, I got 12.5.
Yes, very good. Whoa. Okay, 12.5. Whatever. I don't know what the units are. I don't know. We'll look at that. You can look at that at the top. Days, 12.5 days. They do want to.
Yeah.
Okay. What is the doubling time for the population? This is really kind of a critical number in these types of problems. So it's basically solving the same thing, except now you want to know when it's 1200 equals 600 e to the 0.044 t. There is a shortcut, okay? Meaning like there is like a known formula for this, but you solve this the same way. Do you want me to show the steps or give you the shortcut?
Shortcut.
Okay, so the time is the natural log of 1/2, negative natural log of 1/2 over, I'm sorry, natural log of 1/2. Sorry, I'm getting this all messed up because I am tired too. Natural log of 2 over 0.044.
Okay. Got it.
So we do need a number for this. Let's go double check.
I got 15.8.
Yep, really good, really good. Okay, you said to go to 21 next.
Yes.
All right, we don't have enough time probably for me to show you, but I'll talk you through it. So you have to put, you have to go to your graphing calculator and you go to list, and the ages are going to go in list 1 and the premiums are going to go in list 2. Okay, so the I think it's like stat edit, maybe. You put your data in list 1 and list 2, and then you do a stat calc. And then the exponential function, gotta look, see which one it is. I'm wincing because I don't remember here. Let me grab mine real quick, the calculator here.
Okay.
So stat edit.
I don't have the right calculator right now, but like I know how to get there.
Yeah, so this is, it's 0, which is exponential reg. You might double check with your teacher. Sometimes they mean power regression here. So once you get the equation to do part B, you just put the numbers in, like it'll tell you, E34, E to something, and you just put the number in, just like we did for 20 or 19, sorry. So there'll only be one variable, and that variable, you'll put in x equals 70 into that. All right, for 22A, to do part A, you have to find P of 0. I'll just leave it at that. To do part B, what you're doing is you're figuring out what happens as T gets really, really large. Okay, and to do this, you have to like think about, well, what happens? Is that right? Is that not a negative?
Oh, I don't see any negatives
I
on
don't
that one.
either. What is the max percentage of people with carrying capacity that do not own a computer? Okay, never mind. That's something different. So the carrying capacity, sorry, the carrying capacity, this would be in your book also. So I'm just trying to look up it's the ratio to the letters.
Okay.
Right. So in this problem, I believe it is just the 95.4993 divided by the 1, which is the 90. It's about 95.4993%. So there's like coefficients here. It's this leading top number over this other number.
Okay.
So, all right. I know we didn't get through everything, but we do have to stop here, unfortunately.